Hello everyone, welcome back to the channel. So my name is Arun. I'm a technical trainer in Network as Home. So today we're going to discuss something about the top most 20 asked BGP questions. So let's start with that one. So it may help you in the interviews. Okay. So the first question will be like, what exactly the BGP is? The first question they will ask is, what is BGP? What is that? It's a border gateway protocol. So this border gateway protocol is used to exchange the routing information between the different autonomous system on the internet, basically, which is used in the ISP or the internet just to change some routing information between the ASs. It is not like the IGP. It is used in the EGP, exterior gateway protocols, which will help us to exchange some routing information between the different ASs. So this is called what BGP is. And the second question is like, what are the types of the BGP? So majorly we have two types in the BGP. First one is iBGP and second one is eBGP. iBGP stands for what? Internal BGP, that is border gateway protocol, and second one is the eBGP, external border gateway protocol. So when it comes to the iBGP, which will send or exchange the routing protocols within the same AS, and the second one is eBGP, where it will use to send the routing information between the different ASs. So these are the two different types of a BGP. So the third question which comes is like, as I was talking about the AS autonomous system. So what exactly this autonomous system is? The third question is what is an autonomous system is? So an autonomous system is a collection of IP routing prefixes under the control of single entity or organization, you can say, that will present a common routing policy to the internet. So it's a collection of different IP routing prefixes, so within the same organization, which will help us to send the routing information to the different ASs or within the same ASs. Okay, so the fourth question is like, how does the BGP differs from IGP? As I already said you, we have two types in the routing. So one is the IGP and second one is the BGP. And first one is the IGP and second one is the EGP. So IGP stands for what? Interior Gateway Protocol, and EGP stands for Exterior Gateway Protocol. So in IGP we have a lot of dynamic protocols where we we do the routing things. And EGP is what? We have only one protocol, that is BGP, where it is also called as what? Path Vector Protocol. So BGP, which will give the inter-domain routing protocols, which works between the different autonomous systems. And whereas the IGP, just like as I already said you, we have some different dynamic protocols in the IGP, just like the OSPF we have, and the EIGRP we have, and the RIP we have. So this will operate within the same autonomous system number. So this is what the difference between the BGP and the IGP is. And next question is like, the fifth question, what is the BGP AS path attribute? So just like we have in IGP protocols, the metrics, how they find the best path to reach the destination. Okay, same the thing we have in BGP also, that is called AS path attribute. So this is kind of a metric which is used in the BGP, border gateway protocol. So which is a well-known mandatory attribute in BGP, and that lists the ASs a route has traversed, used for loop prevention and path selection. So you already know that routing is nothing but what? Which is used to get the best path to reach the destination. So in BGP, which will send the routing information between the ASs, it uses a attribute or a metric called AS, autonomous system path. So each router which will send its AS numbers to the next router, okay, whenever they are sending the routing information. So this AS path will help us to prevent the loops which are created, and it will also help us for the path selection, best path selection. Okay, and the sixth question is like, what is the function of BGP next hop attribute? So this is a next attribute what we use to select the best path in BGP. So next hop indicates the next hop IP address that should be used to reach a destination, and it will help us forwarding the traffic to the next network, or even you can say next EOS also. So whenever you are sending the data traffic or a routing information, so next hop is it's very important. So this will give you the path to reach the next network, or even to give the next router. Okay, so that's what next hop is. Whenever it comes to the eBGP, eBGP will send whenever it is sending the information about the routers, it will send the next hop information. And when it comes to iBGP, they will not send the same next hop information will be given to the internal routers whenever it is using the iBGP in the same AS. So this was a sixth question. And the next question is like, how does BGP prevents routing loops? So whenever, as I already said you, whenever they are sending or exchanging the information of routing, what the routers will do, they will exchange the AS path attributes. As I already said you, AS path is a kind of a number, AS path number, or ASN I can say, that is autonomous system number, which will help to create the BGP table. So based on this only the routing will be done. So BGP uses a AS path attribute to detect and prevent routing loops. If the BGP route sees its own AS number in the path, it rejects the route. So let's suppose like we have some 5 to 6 routers. So router 1, whenever sending its own BGP information to the neighbor router, so it will give its own AS number also. So when it goes and goes to the router 2, and router 2 also add its own AS path or AS number or ASN I can say, and again it will go to router 3, and router 3 also have its enters the AS number into that same table, and again it will go to for router 4 and router 5. And let's suppose like router 5 is advertising this same routing path or AS attribute or AS path attribute. If it comes to the router 1 with the same AS path, then it is going to be rejected. So this is how it is going to prevent the loop if it is getting created in the network. Okay, so this was the 7th question. And the 8th one is what is a route aggregation in BGP? So route aggregation is nothing but what? It's same like the route summarization. So route summarization means what? Here we are going to reduce the size of routing table. So just instead of sending the whole lot of routes, so what we are going to do, we are going to summarize the routes what we have currently. So let's suppose like we have 4 networks like 192.168, 1.0, 2.0, 3.0, 4.0 with a slash value of 24. So we are not sending the whole 4 networks. So instead of that, what we will do, we will just send 192.168.0.0 with a slash value of 22. So this is how it is going to reduce the routing table, and it will be sent towards the next router. So because of this, the size of the routing table will be reduced, and even the lookup of this routing will also be reduced. So this will minimize the processing of the CPU. So this is where we use a route aggregator. And the 9th question is like, what is a BGP peer? So BGP peer is nothing but what? It's the same like a neighbor only. So where a BGP peer is nothing but, or a neighbor is another BGP speaking router with which routing information is exchanged. Like if the routers are connected in a network and they both are configured with the BGP, and obviously they are going to exchange some messages. So when they exchange the messages, they will find the neighborship. So this is called as what? BGP peer. And whenever they will speak in a BGP manner or protocol, so they both are called as what? BGP peers or BGP neighbors in the network. And the 10th question is like, what is the difference between iBGP and eBGP? So I think we already discussed about it. So iBGP operates within the same AS and does not modify the next hop attribute, while the eBGP operates between the different ASs and it does modify the next hop attribute. So as I already said you that iBGP works in the same AS, that is a autonomous system number, and where whenever it is sending the routing information to the neighbors which are there in the same AS, they will not modify the next hop because that will be getting it from the external BGP. Okay, same will be given to the internal routers. And when it comes to eBGP, which works in the different ASs, so there it is going to exchange or modify the next hop information. So this was about the difference between iBGP and eBGP. And the 11th question is like, what is the BGP decision process? So as we have seen in the IGP routing protocols, just like the RIP protocol, OSPF protocol, and even the EIGRP protocol. So RIP protocol we used to find a best path using the least hop counts, and OSPF use the cost, and EIGRP use the composite metrics or bandwidth, the delay, these kind of things. So but when it comes to BGP, it uses some different attributes. The first attribute is what? Wait. So after that it uses a local preference. After that it uses AS path, origin, MED, eBGP or iBGP, and router ID to select the best route if it is having a multiple paths to reach the destination. So this is how the BGP routers will find the best path to reach the destination router. And the 12th question is like, as I already mentioned you, there is a attribute called MED. Okay, so what exactly this MED attribute in the BGP is? So MED stands for, first of all, MED stands for multi-exit discriminator, which is going to suggest to external neighbors the preferred path into an AS when the multiple paths exist. So whenever, let's suppose like we have a router and which is having some multiple paths to get inside the same AS. Okay, and if it is having a multiple paths, the multi-exit discriminator, it is going to suggest that this is the best path by giving the lowest MED value. Okay, so let's suppose like I have two routers, R1 and R2. Okay, so R1 is having MED value as 100 and R2 is having MED value as 200, and both are connected with the ISP. So ISP will always go with the lowest MED value. That is all. In this scenario, it is going to go with the R1 because it is having the MED value as what? 100. So that's the reason MED is kind of an attribute which will also help us to find the best path to reach the destination. And next question is like 13th question. What is a local preference in BGP? So local preference is used within a same AS to indicate the preferred path for outbound traffic. Higher values are totally preferred. So what is this local preference? So let's just now only we discussed about the MED. So where it is having, if it is having a multiple paths to reach the destination or get inside the network, so it will always go with for what? Lowest MED value. What if it is having two multiple paths to reach the other network? In that case, local preference will help us. So always if the routers are having local preference values higher, that will be preferred for the best path. So that's what the local preference in BGP is. And the 14th question is like, this is what is the wait in BGP? So wait is what? It's kind of a first preference just to find the best path. So it is a Cisco specific attribute used to influence the best path selection. So always it's kind of a Cisco proprietary which will use to find the best path whenever it is having a wait, and this is the first attribute which is considered. And higher wait is preferred and it's local to the router. As I already said you, this is totally restricted to the single local router which is not given to the other AS. Okay, and it will always consider the highest wait. And the 15th question is like, what is a BGP route reflector? So a route reflector is used to reduce the iBGP full mesh requirement by reflecting routes to other iBGP peers. So first of all, we'll discuss what is this full mesh is. So full mesh means what? Here every router which are present in this topology, they have to have the exact information in the whole network. So they have to have a proper and a full routing table which are having with all the other routers in the topology. So that is what called full meshes. And to have this, okay, so we can't distribute the whole full mesh information to all the routers, because that will be again traffic on the network. So just to stop this one, we use a router as a route reflector. So here we'll be having some router roles like route reflector and a client and a non-client. So route reflector is kind of a router which will send the routing information to the clients or non-clients. For example, if we have 3 routers, so router 1, router 2 and router 3. So we are going to make the router 2 as a route reflector. So where the client devices like router 1 and router 3, they are being the client routers. They will just send the routing information to the route reflector, and that route reflector is going to send the information to other client devices, and the non-client will not going to accept, or they are not going to be sent any kind of routing information to that non-client devices or routers, I can say. So this is what the route reflector is. So 16th question, what is a BGP confederation? So confederation divides an AS into some multiple sub ASs to reduce iBGP mess and still present as a single AS to external PS. So basically what we are doing in confederation, here we are going to divide the single AS into some sub ASs. For example, if we have a AS called 65,000, so here inside this we are going to create some 65,001, 65,002, 65,003. So here it will be inside the same AS, so that will not be reflected to the different AS. So this is called as what? BGP confederation. So here sub ASs, they are going to reduce the iBGP mesh. I mean, it will be happening inside the same AS. It will not going to be reflected towards a different AS. Okay, so this is what the BGP confederation is. So the 17th question is like, what is a BGP community? So communities are tags that can be attached to routes to influence routing decisions or policies. So think like it is an label or a tag which is attached to the routes to help with a routing policy control, such as filtering, preference or a redistribution. So what happens in the BGP community? Here we are going to make a group of routers. So where we can give a proper filtering or a proper policies that can be applied to all the routers which are there in the group at the same time. So this is why we use a BGP community. So which will be kind of a tag or a label. So because of that label, or with the help of that label, we are going to apply the filtering or a preferences or redistribution of the network or protocols, routing information what we have. And 18th question is like, what is soft reconfiguration in BGP? So soft reconfiguration, which will allow the BGP to reapply inbound policies without resetting the session by storing the received routes. So what exactly the soft reconfiguration is? Which will allow the BGP routers to apply new inbound routing policies without resetting the BGP session. So currently with some of the BGP sessions are going on, so without affecting those, how we can give the new policies or new inbound routing policies we can be given to the routers. Okay, so there that is called as what? Soft configuration or reconfiguration. It's mainly used for inbound updates, and it is useful whenever you want to change filters or route maps and see their effect immediately. So if you want to change any configuration without changing or making any effect to the currently running scenario or currently running configuration, so in that case it should be enabled with the soft reconfiguration. That will not going to affect the current running session. So without that only we can check the effect of that reconfigured policies on immediate base. Okay, so this was the 18th question. And the 19th question is like, what is graceful restart in BGP is? So graceful restart allows BGP routers to preserve forwarding state during a control plane restart. So basically this graceful restart is kind of a BGP feature that allows routers to preserve forwarding information and avoid routing flaps during the temporary control plane failure. So just say like if the session got ends or something happens to the control plane during this BGP session, so in that time what the graceful restart will do without affecting the other session, okay, it will preserve the forwarding state, okay, during the control plane restart. For example, if the BGP restarts or something happens to the current running session, so without affecting that one, this graceful restart will maintains the same process until it gets it over. Okay, so the 20th question is like, what is the purpose of BGP timers? So as like we have some different timers in RIP protocol and the OSPF and the EIGRP, just like the hello packets or hold packets or something like that. So here also we have some different timers. So those are like mainly keep alive and hold timers. So BGP uses two timers like keep alive and hold timer to detect dead peers and maintain session stability. So what exactly this hold timer is? It's a maximum time a BGP router will wait without hearing a keep alive or update from its peer before declaring the session dead. So what is this hold timer is? Like, let's suppose like the session is got established between the two BGP routers and they are exchanging the routes, and for some reason or some any reason, one router, let's say like router 1 and router 2 got off. Okay, in that case what happens, the router 1 is going to wait for the default 180 seconds. So after 180 seconds, the router 1 is going to remove the routing information of that router 2, which was the neighbor of that one. So this is what hold timer. So till then it will be waiting for that till 180 seconds. It will be waiting for that neighbor to get up. Okay, so once it gets up, again the session will be established or re-established, I can say, and then they will again start to exchange the packets. Okay, so this is what the hold timer is. And what is this keep alive interval or timer? So keep alive is nothing but what's kind of a hello timer. For every 60 seconds, both the neighboring routers will be checking the health of each neighbor routers. So why they will check? So if the again we'll take the router 1 and router 2. So if the router 1 is sending the keep alive message towards the router 2, and if it is getting the reply, okay, after 60 seconds, then it seems like the neighbor router which is connected to me, it is totally alive and it is working. So for example, how often a router sends a keep alive message to its BGP peer to prevent a hold timer for expiring? So let's suppose like again just to consider the peer is dead or it's not working, so we will just exchange the keep alive messages for every after 60 seconds. And next is, the 21st question is like, how is BGP convergence time? So first we'll see what exactly the convergence time is. So BGP convergence time refers to the amount of time it takes for the BGP routing tables across a network to become consistent and stable after a change. So let's suppose like we just added a new route with the topology, or we just withdraw a route from that topology. So in that case, every router should be know this one. Every router should be updated with the same information. So the timing it took, the whole router's take to know this one, whether there is a added a route into the topology or some route which is been a withdrawal from the topology. So whatever the time it's take, so this time is called as what? Convergence time. So when it comes to BGP convergence time, it is really slow because it uses a path vector protocol. It is a path vector nature because always it will send the AS number, okay, just to find the best path. Okay, so it has a slower convergence due to its path vector nature, and reliance on the TCP protocol. So 22nd question is like, what is BGP dampening? So BGP dampening suppresses a route that flap frequently to stabilize the network. So this is kind of a mechanism which is used to suppress the unstable routes in the BGP. Let's suppose like one route which is going up and going down frequently. So this is called as what? Flapping of that route or network, I can say, which will affect the unnecessary churn in the network. So just to stop this one, we enable BGP dampening in the network. So which will temporarily penalizes and suppress that particular route to maintain the stability in the whole network. So this is called as what? BGP dampening is. And the 23rd question is like, what is the BGP open message? So it's kind of a hello message, I can say again. So open message is used to establish a BGP session and exchange capabilities like ASN and hold timer. So open message, it will not just like a hello message just to say hello to the routers or neighbor routers. It will carry some of the information with it. Okay, just to check that is my neighbor alive or not. Okay, so whenever it is exchanging the open message with its neighbor, it will carry the information like version of that BGP. Basically, it will be version 4 of the BGP, and what is its own AS number. What is the AS number of it? So that will also be exchanging with the neighbors. And what is the hold timer? I mean, again, it's kind of a dead timer, I can say. And BGP identifier just like a router ID and the optional parameters length and optional parameter. So this kind of information will be carried with the help of this open message to the neighbors. And the 24th question is like, what is the use of BGP update message? So update messages are like which is going to advertise new routes or withdrawals previously advertised in the routers. So let's say like I just added a new route or withdrawal or deleted a route from that topology. So that should be flooded to all the routers, right? So in that case, whatever the message will be flooded, that message is called as what? Update message, which is used to advertise, withdraw or change routes between the BGP peers. So which will be advertised to the neighbors just to know that this route or this network which is been added in the network or it is been withdrawn from the network. And the last question, that is 25th, what is the BGP notification message? So this message is used to report errors and close a BGP session. So a BGP notification message used to report errors and immediately terminate a BGP session. So just because of some misconfiguration, so it is going to affect the whole topology. So just to end this session or turn down this session, we use this notification message. So which will be giving the reports of the errors just to close the BGP session which is currently running. So these were the mostly asked BGP questions during the interview. So I hope it will help in your interview. So thank you. Thank you for your time and keep supporting and please subscribe our channel.